Okay, good morning everybody. So this morning, I will be performing exercise number 3, which is about the properties of protoplasm. Okay, so I will be introducing to you the materials that we will be using. Okay, so first we have the compound microscope. Okay, and then of course we have the alcohol lamp. And then we have beakers. Okay, and then also we have slides and empty slides. Okay, and then test tubes. Okay, and then of course test tube holder. And of course test tube rack. Okay, this is where I will be putting all the results after the experimentation. And of course we have here several chemicals that will also be used in discovering the properties of the protoplasm. For exercise proper, okay, so we will be having several tests, okay, to discover the properties of protoplasm. So we have dispersal system, and then we also have tests for organic compounds, okay, and then of course we have the test for the presence of fats and lipids, okay, and then also test for the presence of proteins. Okay, so first we have solution. Okay, so a dispersal system. Okay, so in solution we will be needing a test tube and place a half water to fill up at least half of the test tube, and then we put a pinch of salt. Okay, so this is the salt. Okay, so let's put a pinch of salt into the test tube with water. Okay, then after that we set aside and observe what happened later on. And then with the suspension, okay, so we need another test tube and place water also half filled. Okay, and then we also put a pinch of flour into the test tube with water. Okay, there. And then also we put this, we set aside this, okay, and to observe the result after 20 minutes. Okay, so we're done with the solution and suspension, and right now we'll do the emulsion. Now in emulsion we need to have a test tube, okay, and then with a 5 ml ethyl alcohol. Okay, so this is the ethyl alcohol, and we use a clean dropper, okay, and extract some alcohol and place it into the test tube. Okay, at least 5 ml. Okay. And then we add 3 drops of vegetable oil. Okay, so here's the vegetable oil. Okay, and then also we use another clean dropper and extract some oil and put at least 3 drops. Okay. And then observe what happened. So that's the ethyl alcohol with the 3 drops vegetable oil. Okay, so and then we shake it well and then observe. And then into the 5 ml beaker with half filled water, we put or place this ethyl with the oil into the beaker. Okay, and then shake. Okay, and then afterwards, we extract a little from this mixture. Okay, and then place a few drops on the slide. Okay, and then of course we cover this with cover slip. Okay, and after that, we place this under the microscope. Okay, using a low power objective. Okay, so we observe. Okay, so examine and observe and record the observation. Okay. Okay, so next we do the sol gel state. Okay, now we soak half gram of agar in a test tube that is half filled with water. Okay. Okay. And then we warm this gently over an alcohol lamp and wait until the agar dissolve. Okay, so while we heat over alcohol lamp the test tube with the agar that is soaked with water. Okay, so observe what happened. Okay, so we wait until the agar is dissolved. Okay. So, what happened? Okay, and then we immerse this, okay, to a beaker with tap water. Okay, and then observe again. Okay, so what we did earlier, we soaked the agar to a test tube that is half filled with water, and then we warmed it gently over an alcohol lamp. And then when it became semi-liquid, we immerse to a beaker with tap water. And this is the result of the agar when we immerse it to a tap water. So it became solid. Okay. Then after this, solid or gel-like. Then after this, we reheat it again, and then let's observe what happened. Okay, so when reheated, what did you observe? Okay, so the gel-like, okay, again, became semi-liquid. Okay, so meaning to say, one property of protoplasm here is colloidal. Colloidal system, meaning to say that it can undergo reversible sol gel, of course, depending upon the pH and temperature. Okay, now this time we'll test for organic compound. Okay, so we have here presence of carbohydrates. So in presence of carbohydrates, we will have two tests, and that is testing for monosaccharide and the presence of polysaccharide. Now, in test for monosaccharide, we prepare two clean test tubes, and then we label test tubes 1 and 2. Okay. In test tube 1, we place 5 ml of glucose solution. Okay, glucose solution, 5 ml. Now remember that in every ml, there will be 20 drops. Okay. Okay, so this is the test tube 1, which I put a glucose solution, and then I'll be dropping 5 okay, drops of Benedict solution. Okay, so this is the Benedict solution. So 1, 2, 3, 4, 5. Okay, so that's the 5 drops of Benedict solution, and then we boil this mixture. Okay, so we boil this. So take note of the result. Okay, what happened after I boiled this mixture over an alcohol lamp. So as you can see, the mixture is changing its color. Okay, so observe what color did it give off. Okay. Now next is the test tube number 2. Now in test tube number 2, again, I will fill this up with a starch solution. Okay, so this is the starch solution. And then again, we add 5 drops of Benedict solution. Okay, so we boil this for 2 minutes. Okay, so again, observe what happened. Did the color change? Okay. So this is with starch solution and Benedict's solution. Now again, another test for presence of carbohydrates is the test for polysaccharide. Now we again prepare another 2 test tubes. Okay, and the label is test tube 1 and test tube 2. Now in test tube 1, we place 2 ml of the starch solution. Okay, that is test tube 1 with starch solution, and then for test tube 2, we place glucose solution. Okay, also 2 ml of glucose solution. Okay, now with both test tube, we place the IKI, or we call this as the Lugol solution. Okay, Lugol's solution. So we put or add the IKI to tube 1, test tube 1. Okay, then observe what happened. Okay, so is there a change of color? Okay, so what color? Okay, and then in test tube 2, okay, which is the Benedict solution, the glucose solution, we also place a few drops of IKI, or the Lugol's solution. Okay, so what did you observe? Did the color change? Okay, so record all the noted results. Okay, to continue, this time, let's test for the presence of fats and lipids. Okay, now for the diet test, okay, so we fill test tube with 10 ml of water. Okay, and then we obtain the Sudan. Okay, the Sudan powder. Okay, and then place it here in the test tube. Okay, we add a little more. Okay, so we shake well and then observe. Okay, so what happened? And then we add 2 ml of oil, and then okay, 2 ml of oil, and then we shake this. Okay, we shake this and then observe. We will let this stand at least for a minute, and then we take note of the result. Okay, now this time we'll have the grease spot test. Okay, so in a 1/4 sheet of clean bond paper, we place at least 2 drops of oil. Okay, 2 drops of oil, and then you observe. Okay, so what happened? Okay, with the bond paper that is being dropped with 2 drops of oil, or here. Okay, so what happened to the paper? Okay, so this is the result of the emulsion when ethyl alcohol is added with drops of oil. So, in your observation, where does the oil went and what happened? Okay, next we'll do the presence of protein. Now, in the presence of protein, we have 2 tests. Okay, one is the Burette test and the other one is the coagulation test. Now, with the Burette test, I will be placing, so this is the egg albumin, 2 ml, okay, in this test tube. Okay, now I will be adding 10% of the sodium hydroxide, okay, into this test tube. Okay, at least 1 ml no, of sodium hydroxide. Okay, and then I will be covering the test tube with the cork and shake. Okay, so after shaking this, I will be adding copper sulfate, a 1% copper sulfate. Okay, observe what is happening as I add a copper sulfate. Is there a change of color? So in here, I kept on adding copper sulfate until I observed that there is a change of color. Now, as you can see here, okay, so since I am near, from my point of view, I can see a formation of a ring, violet color. Okay. Okay, now with the coagulation test, okay, so I have here another test tube with 10 ml of water, and I will be adding a small amount of albumin, egg albumin. Okay, and then I will be inserting a thermometer, okay, without touching it to the bottom. Now observe that temperature here is 22 point, okay, 23.6. Okay, and then I will slowly, okay, heat this over an alcohol lamp and observe at which temperature the small particles would start to appear. Okay, so did you get that? Okay, so at which temperature, okay, the solid particles appeared. Okay, to continue with the coagulation test, again we prepared 2 test tubes, okay, labeled 1 and 2, and both test tubes I added a 5 ml of egg albumin. Now with the first test tube with egg albumin, okay, so I will be adding a strong or concentrated hydrochloric acid. Okay, so that's hydrochloric acid. Okay, and then with the test tube, with the second test tube, I will be adding a strong, okay, sodium hydroxide. Okay, there. Okay, so we will be observing, okay, what happened to test tube 1 and test tube 2. Now with the test tube 1, okay, so with the hydrochloric acid, okay, observe the result. Okay, so here we find that there is a curdling, the curdle, okay, of the egg albumin, while in the sodium hydroxide, okay, so it remains clear and transparent. Okay, so the other one is cloudy and it curdled, and the other one is transparent.